Roughly 250 miles off Mexico's Pacific coast, rugged islands rise steeply out of the sea.
It's one of the most spectacular places in the world.
This is the remote Revillagigedo archipelago.
It's just absolutely magical. There are 4 islands in the archipelago de Revillagigedo, known as the Socorro Islands. So there's San Benedicto, Socorro, there's Clarion, which is the furthest out, and then there's Roca Partida.
They have had their origin as volcanic structures rising from the seafloor, and they were all active volcanoes at one time. And those islands are not inhabited by people and not frequented by weekend sailors. They're too far away.
These far-flung islands are popular with die-hard scuba divers who visit on liveaboards.
It's a bucket list dive site.
The divers come for once-in-a-lifetime encounters with the gentle giants that travel the open ocean.
And they're like giant airplanes that start to fly in.
They are so big, so elegant, and so beautiful.
Diving with the mantas is undescribable. I can even say that it's a spiritual experience. The mantas, they're warm and they're friendly and interactive, and they like to feel your bubbles on their belly and they react to it.
I've studied mantas both in the Galapagos and at Cocos, and while they're beautiful and unique in their own way, they don't show the kind of interest in people and the interaction that we've experienced here.
This unique behavior led the United Nations Educational, Scientific, and Cultural Organization, or UNESCO, to declare the Revillagigedo archipelago as a World Heritage Site in 2016. And it isn't just giant mantas that frequent the islands.
You see different types of sharks: white tips, silver tips, black tips, silky sharks, hammerheads, tiger sharks, Galapagos.
Revilla is special for the numbers of different species in very small areas.
Even though these islands are relatively small, they provide a fair amount of protection, and there's an abundance of food.
The island's distinctiveness has earned them the nickname Mexico's Little Galapagos.
There are some animals found at the Revillagigedos. The fish are found nowhere else in the world. That uniqueness makes them intriguing to biologists because you're essentially seeing evolution in action.
What can scientists learn from the ocean giants that come here? How do they use these island habitats?
Major funding for this program was provided by the Batchelor Foundation, encouraging people to preserve and protect America's underwater resources. And by Divers Direct, Emotion Sports, inspiring the pursuit of adventure and water sports. The Do Unto Others Trust. The William J. and Isabel G. Clark Foundation. And by the following: Lady Susanna P. Tweed and Carlton Tweed Charitable Foundation, Skip and Diane Day.
It takes more than a full day's journey from Los Cabos on the Baja Peninsula to reach the archipelago by boat.
Part of the California current.
Dr. Robert Rubin, who heads the Pacific Manta Research Group, first encountered mantas in this remote island chain in the late 1970s.
I've always been intrigued by mantas, in large part because there was no scientific knowledge really of note. I think they're one of the most beautiful designs I've ever seen. And I think that it's important to be intellectually intrigued and also emotionally involved in one's work. The first work that was undertaken by mantas, at least in the Pacific, that I'm aware of, was the work that we started in the Sea of Cortez and to a lesser degree at the Revillagigedos. And it was mostly just natural history. I thought at the time that they were very rare, and that most people thought that also. If you saw one, it was pretty exciting.
In those early days, Dr. Rubin focused most of his manta research on the Sea of Cortez.
And they were abundant at lots of sites. And then gradually they were less abundant, and this correlated with the abundance or lack of the big sharks, hammerheads, makos, others. I spent most of a year in the early 90s looking for them at the sites that I had seen populated by large numbers in the past. And in that year of searching, I didn't see a single manta. I didn't see them in the ocean, and I didn't see them in the fish camps, which you'd occasionally see where they'd been caught. The last manta that I saw in the Sea of Cortez was in the mid-'80s.
Years of heavy fishing pressures had decimated the number of mantas in the Sea of Cortez.
The transition to Socorro and the adjacent islands occurred when we realized that we couldn't work in the Sea of Cortez any longer. They were gone.
Oceanic, or giant manta rays, are currently listed as vulnerable by the International Union for Conservation of Nature.
Mantas have been thought of as endangered or threatened. We really don't know, to be quite honest, because we've only started to understand where the populations are. When I first started working on this, I was the only person in the world that was working on them. But now there are lots of people that are interested, and the assessments are starting to become more sophisticated. The population sizes seem to be larger than I would have ever predicted, but they are likewise isolated in certain regions.
Early observations of the animals showed that individuals can be identified by their appearance.
The color patterns of mantas seem to be highly variable, so we can recognize them individually. There are two color forms. The black morph is very unusual and rarer, a beautiful, elegant beast. And that animal is often seen within groupings of chevron mantas, which is a lighter animal with patches of white on its shoulders and V-shaped designs on its wings and posterior upper body. And then underneath, they're white with black markings. And that seems to be the most common form, and in places of the world, it's the only form that appears. The pattern of the shoulder patches on the top, and to a little bit lesser degree, those underneath, are habitat specific. So you can see a picture of an animal and say, yes, that picture was taken in Mexico, or that was taken in Africa, and so on. And that led to some of the early ideas about there being different populations.
Mantas are found in tropical and subtropical oceans across the globe.
Up until about 10 years ago, it was thought that there was a single species of manta worldwide. And as more and more people started to study them, we realized that there were some rather significant differences. Mantas are now classified into two separate species, and there may be a third actually now in the Atlantic. But the two that are well defined are referred to as the oceanic manta and the reef manta. The oceanic manta is larger in size, and it seems to be more associated with colder, nutrient-rich water that is associated with offshore islands and seamounts, open ocean habitats. The reef manta is about 15% smaller. It has somewhat different markings, and it is more associated with warmer water and reefs. So as we look through it,
Over the years, Dr. Rubin and his team have put together an extensive photo identification guide that helps them keep track of individual animals.
we established a photo catalog that now has about 30,000 plus photographs in it.
Divers visiting the islands are encouraged to submit their images to help with the research.
All sorts of folks from all sorts of different walks of life in the world send us pictures, and they have been instructed or asked to give us at least one perfect image of the animal's belly. And boy, we've got some great photographs. We identify them based on 5 different characters in the marking. We can then match them, and this is kind of a key, and you do it by somewhat of a process of elimination. It has these markings, it does not. If it does not, you go over here. If it does, you can follow up. And we keep track of when we've seen it, where we've seen it, and so on. And so we know about a little over 600 different animals, and about 250 we've seen more than one time. We see new ones on every trip, so it just means that the population is growing or we're learning more about it.
Acoustic tags make it possible to track the animal's movements.
Those tags are attached to the mantis themselves with a small dart right underneath the skin. They have a battery life of about a year, and they come off the mantis fairly readily.
The acoustic tags send out sound signals that are recorded by underwater receivers.
They're extended from the seafloor by a float, and they're listening for the tag. They're also recording time of day and water temperature, so we know when the animals are present and when they're absent. Unfortunately, the tags have a very limited range, a little over a kilometer maybe. They come into a location around an island, and they may be around for 20 minutes or 30 minutes, and sometimes for a couple of days, and then they're gone. And then maybe we'll pick them up at another island. We know that they're moving between islands, sometimes the same day, so it's not uncommon to see an animal at one site and then the next morning see it at the new site, which is separated by maybe 60 kilometers or so. So they can swim fairly quickly from place to place.
The receivers are located throughout the archipelago, as well as in the Sea of Cortez and along parts of Mexico's Pacific coastline.
They move between San Benedicto, Socorro, and Roca Partida, and they're moving back and forth into the southern Sea of Cortez and maybe up north as well. We're starting to see them in places that I have never seen them in the past. They're not abundant, but they're here and there, which is very encouraging. We also see them moving from the Revillagigedos south into Bahia de Banderas, which is around the resort city of Puerto Vallarta, and even further south than that. So we think that the population in the islands is acting as a recruitment site, and that's very encouraging because if they're protected now in the Sea of Cortez and other places, it looks like they'll repopulate it, and we're excited about that potential.
Dr. Rubin shares the receivers with Mexican scientists who study other animals. One of them is Frida Lara Lizardi, a PhD candidate who works for Pelagios Cacunja, a nonprofit dedicated to the recovery of marine predators through science-based conservation.
My PhD is about the distribution patterns of the sharks. And first I started especially in Revillagigedo or Socorro Islands. And then as the years passed, I also study other marine reserves like Cocos, Malpelo, and Galapagos. So I'm looking for the connections between the marine reserves in order to protect some species of sharks like Galapagos and silky sharks.
Frida began her research in the archipelago by setting up baited cameras on various dive sites.
I wanted to see all the sharks that are around the area, and I found 8 species.
Frida is also using acoustic tags to study the movement of sharks.
We have been following the movements of 23 Galapagos sharks and 24 silky sharks that has been tagged since 2008.
The research shows that the sharks travel back and forth between the islands, putting them at risk of being caught by fishermen. Shark populations have been on the decline in Mexico, and in 1994, the Mexican government established the islands as a biosphere reserve. Currently, there is a no-take zone in place around each island that extends out for 12 miles from the shore. But scientists argue that isn't enough.
For us, it was very important to prove that the sharks are doing these movements between the islands because there are some areas between the islands that are not fully protected. So all the fishing boats can go there and exploit tuna and also some sharks. Not just Galapagos and silky sharks, other sharks like tiger sharks and silver tips are also using these 3 main islands, and they are moving between these places. So we think if we protect these areas, we can protect a lot of species. The proposal is to cover a bigger area around the islands. So doing that, we can cover a triangle between the islands, and then protect these sharks.
Using their research findings, Pelagios Cacunha is working closely with Mexican authorities to extend the protected areas. Past research has shown that marine reserves that are closed to fishing don't just allow local populations to recover, but they can actually create a spillover effect into unprotected areas.
Socorro Islands or Revillagigedo are very important because in Mexico is the only place that you can find this number of species. I think as Mexican we have the responsibility to protect this place and to show that it's important for us.
One of the main reasons that I feel that Revillagigedo or the Socorro Islands need to be protected is because it is so remote, and an issue we have out there is the illegal fishing. And so we need to make the policyholders understand that they need to have vigilance all the time at the Revillagigedo Islands.
Mantas, too, are affected by fishing pressures.
We lose so many of them to fishing, sometimes intentionally killing them, sometimes killing them by accident, stuck in the nets.
While mantas are now protected in Mexico, they are killed in other parts of the world for their large gills, which are used in traditional Chinese medicine. Mantas have very large mouths, and they use modified gills to filter their food out of the water.
One of the major mechanisms that you see in mantas is the modification of these pectoral fins into feeding devices that we call cephalic fins. They look like large spatulas coming off the sides of the face around the mouth, and those are used in feeding. When the mantas swim in the open water and they're not feeding, they roll them up like a newspaper, and it reduces the drag on the swimming motions. But when they feed, they open them and drop them down around the mouth like large scoops and open the mouth. And with them, they create a vortex of water that cycles into the mouth.
Mantas filter large amounts of water to feed on tiny animals called zooplankton. This is what got PhD student Tanya Pelamati interested in studying mantas.
2 years ago, I had the opportunity to go to Revillagigedo Islands for the first time. And when we jumped in the water and there were those beautiful animals swimming elegantly in the water, I completely fell in love. And I said, I want to study them. I want to work with mantas because I think they are the most beautiful animals I've ever seen. This is my dream job.
Tanya is curious if the filter feeders are negatively impacted by plastics in the water.
I was thinking about the quantity of water they filter every day, and so during all their long life, how many plastics would they get in contact with, and how can they affect them?
The island's beaches are generally off limits to visitors. But Tanya obtained a special research permit from the Mexican authorities to go on land and collect plastic trash that washed up on shore.
300 miles from the coast, there are a big quantity of plastics. So not even a small island in the middle of the Pacific is free from this pollution.
Winds and currents can transport plastic trash over long distances out into the open ocean, far from their places of origin. It's estimated that between 8 to 30 million tons of plastic trash enters the ocean each year, making it one of the most common pollutants in the sea.
We found 28 shoes. It was clear that they had traveled a lot and they were losing pieces during their time in the ocean. We collected also 51 plastic bottles, and we were looking at the bottles and we saw that 3 of them were from Japan. So it's the proof that plastics can reach every place on Earth. It was pretty sad to find all these plastic objects in such a remote beach.
While large trash is a problem, Tanya is particularly interested in microplastics, tiny fragments that are less than 5 millimeters in size, which could easily be ingested by the filter-feeding mantas.
Manta rays, the size of their food is the same of microplastics. Everyone knows about whales eating plastic bags or bottles or big nets that can entangle animals, but very few is known about the importance and the effects of microplastics on animals. People don't think about it because you cannot see them.
To detect these microplastics, Tanya conducts a number of experiments.
We have been doing samplings with a special net that is made to collect the first centimeters of water from the surface. And so we've been collecting microplastics during 30-minute trawls so that we can evaluate the density of microplastics in the surface zone.
Microplastics come from a variety of sources. Tiny plastic granules are added as exfoliants to cosmetics and as industrial abrasives used for sandblasting. Then there are virgin plastic production pellets and small fragments created by the breakdown of larger plastic trash. Tanya also collected sediment samples on San Benedicto Island to see if microplastics are washed up on the beach. Scientists are concerned about the potential health impacts these plastic particles might have on animals that ingest them. As plastics deteriorate, they leach toxic chemicals like BPAs and others. In addition, persistent organic pollutants, which are present in low levels in the water, will stick to the surface of plastic trash and accumulate there. These contaminants include PCBs, PBDEs, pesticides like DDTs, and other toxic chemicals known to cause serious health impacts, ranging from endocrine disruption to cancer.
So there is the double danger of microplastics. There are the pollutants itself that plastic leach, and the pollutants that are absorbed during their staying in the ocean. The main problem for manta rays is that they can live for more than 30 years. So during this long life, they can accumulate a lot of those pollutants. And so filtering plastics for so many years, it can make damages at many levels.
Tanya also received special permission to collect small tissue samples, which she will analyze to see if the toxic chemicals are present in the manta's bodies. She's comparing populations of mantas in the remote Revillagigedo archipelago to the heavily populated Bay of Banderas on the Mexican coast.
I want to see if those manta rays of a coastal region are more or less impacted by microplastics than Revillagigedo's ones. I have found plastics in both Revillagigedo Islands and Valle de Banderas, and so we are going to see what we'll find in the biopsies. Once you meet manta rays for the first time, you have a special connection with them. When you look into their eyes, you have the feeling that they are such intelligent animals and that we have to do something to protect them.
Much is still unknown about mantas. Manta rays are thought to be the most evolutionary recent and advanced form of living elasmobranchs, the class of cartilaginous fishes that includes sharks, skates, and rays.
They have a number of features that make them more mammalian-like than fish-like. One of them is the way young are raised in utero, and their brains are quite a bit larger than you'd expect for an animal of that size.
Mantas are one of only a few animals and the only fish known to recognize themselves in a mirror.
There's really a suggestion of some kind of consciousness. I hope so. I would like to believe things like that, even though it's not good science.
Mantas have charmed divers and intrigued experts like Dr. Rubin for decades, providing a glimpse into a mysterious underwater world where much is left to explore.
I've loved every minute of it every day. I haven't had very many bad days at sea, and in part, there are days when we get no data, and we have nothing to show for ourselves except the windmills of our mind. And I have been blessed with big windmills, and mantas are big parts of those spinning blades.
Major funding for this program was provided by the Batchelor Foundation, encouraging people to preserve and protect America's underwater resources. And by Divers Direct, Emotion Sports, inspiring the pursuit of adventure and water sports. The Do Unto Others Trust. The William J. and Isabel G. Clark Foundation. And by the following: Lady Susanna P. Tweed and Carlton Tweed Charitable Foundation, Skip and Diane Day.